In addition to these accessor methods, which I should say now that these are actually called instance methods. Okay, these are called instance variables. These are called instance methods. Why are they called instance blah, like instance properties, I guess? Well, the reason why is because each point has its own copy of this x variable and this y variable. And indeed, they all have their own copies of this method, or at least roughly. Okay? By instance method, all that means is that an instance method can access the instance variables of a class. Okay? So this method accesses this variable, and this method accesses this variable. Okay? So let's design another instance method. One that, let's say we will design let's say double distance method that returns the distance from the current point, this point, against another point, another given point, P. Now, this raises a few questions. So, what do I mean by this point? So, what I mean is that, for now, let's just return 0. And, in fact, let's go ahead and write some test cases for this. So, of course, we would write, let's do the full design recipe. So, returns the Euclidean distance from this point to P. P is just another point that we give it, and return distance to P. Okay? So, the actual math behind this is just the distance formula between 2 points. But let's go ahead and just write a few test cases, just for the heck of it. So, one thing I will say is that when you are writing instance methods, it may be tempting. Let's see what's going on here. Okay, let me fix this and I'll come right back. Okay, so when we're testing a class, it may be tempting to test everything, all instance methods of that class. And indeed, we could do that. So for example, we could do point P equals new point 3 comma 4, and then we could say assert equals 3 P dot get X, and assert equals 4 and P dot get Y. Okay? And of course, these would pass, but the thing is, we already know, and this is the case for most classes that you write, instance variables and instance methods should do nothing more, accessor methods should do nothing more than just retrieve the values of the instance variables. So maybe, like, we'll do this one time, but in the future there's no need to do this. Okay? So in fact, we'll just go ahead and get rid of it. Because the main thing we want to do is test distance to make sure distance works. Okay? So let's say we want to compute the distance between, I don't know, let's say P dot, or rather, let's say we want to compute the distance between, let's say this is at 1, 1. So if you want to call, if we want to say, like, we want to get the distance from P to another point P2, let's say 4 comma 5, then we can do that by saying P dot distance and passing P2. Now, I have a calculator up to tell me that that has a distance of 5, and of course, you know, that would be fine for you to do as well, or you could just use the distance formula, it doesn't matter. But the main thing here that's a little confusing is that we're calling this method on the P object and passing it P2. Okay? So when we go inside a point and we actually write the code for this, we're going to have access to P, or rather, let's say this is P2 just to make it extra clear as to what's going on here. Actually, let's call it Q because, yeah. So when we pass in p2, that's going to get substituted for q, of course. But then, what is p? Like, where do we access p's x and y coordinates? Well, we get those from doing this dot. So when we say this dot, all that means is that that is the object, the instance that we are calling the method on. Okay? So when we say this dot inside of the class, it means that we're referencing the data that will be in the object that we are calling the instance method on. And I'm really emphasizing this because a lot of people screw this up. A lot of people don't understand why this works. And the reason why this works is because of something that Java is called the implicit parameter. So think about what this might imply. So there's also something called an explicit parameter. So everything we've seen so far has been explicit. And what do I mean by explicit? I mean that if a method receives a parameter, then you write it. You say int blah or string blah or whatever. You put it inside of the parentheses. Okay? But the way that Java handles calling an instance method on an object is that we say like p.distance, and then we're going to give it some data. Okay? So here, p2 is an explicit parameter, p is an implicit parameter. And the reason why is because distance under the hood is sort of doing something like this. It's like it's rewriting the method to instead pass p as the first parameter and then p2 as the second parameter. Okay? So the implicit parameter under the hood, so if we were to write like double distance, under the hood, Java will be doing something kind of like what I'm writing right here. Okay? So let's scoot that over. So effectively, it's like there's an additional parameter to all instance methods called this. Okay? This is the object that the method is being called on. This parameter is an implicit parameter. Okay? Because you don't see it. You don't do this in Java. You may think, well, at least for those of you who have done Python before, this should look very similar. Okay? Or this should look very familiar. Because in Python, there are no implicit parameters. If you're doing something like def, you might do something like def distance. In Python, if this is an instance method, you actually have to pass something called self and then the second point. Okay? At least I'm pretty sure this is how Python does it. But what this means is that if we want to compute the distance between, it's like, let's say we have a point P and then a point called P2, then when we do p.distance, there actually still is an implicit parameter, but in Python we make it very explicit. Okay? So we usually call it self. I actually don't think it matters what you call it, but you would do something like self dot and then whatever the attributes are. And the same thing for q and whatever the attributes are. Okay? But in Java, you don't make this explicit. You make this implicit, or this is implicit. Okay? So again, this dot is whatever you're calling the method on. Okay? So this dot, so what we want to do, we want to compute the distance between this point, which has an x and a y, and q, which has an x and a y. So again, that's just, we've done this before. It's just the square root of x2 minus x1 squared plus y2 minus y1 squared, and the square root of all that. Okay? So all this is going to be is something where we square then we add something and we square it. So how do we get x2? Well, x2 is just q's x, right? So we can do q dot get x, right? But what's interesting is that we actually don't need to do q dot get x. We could just do q dot x. The reason why is because we're still inside of the point class. We haven't left the point class. So if we're still in the point class and we're working on a parameter that is also a point, we can reference its instance variables directly. We don't need to go through the accessor. Now we could, and in fact we could do something like this. If we wanted to say x1, which is this coordinates, or this point's x, we could actually do this dot get x. Or even more succinctly, we could do just get x. Or even more succinctly, we could just do x. But I think if you're doing this, I think it becomes very unclear as to what is what. So I say this dot x to reduce any confusion. And in fact, this should be a minus, not a plus. So now we're going to do the same thing, but for y. So we'll do q dot y minus this dot y. And then we are done. Okay. So let's run this, and we'll see what we get. And it passes. So, yeah. So this is an instance method that receives a point q. Or so let's back up and talk about everything we did. So we've talked about something called instance methods, and we talked about this notion of something called the implicit parameter, which all instance methods have. So notice that I didn't put the static keyword here. Okay? A static method, as we'll talk about soon, cannot, does not have access to instance variables. And there's a very particular reason why, but we'll come to that later. So if you're defining an instance method, it cannot be static. And that's very important to realize. It cannot be static. Okay? So we defined an instance method that receives one parameter q, one explicit parameter q, and then we said that this is the implicit parameter. It's the one that we call the method on. In this case, it would be p, so the x and y coordinates of this would be 1. And then we just apply the Euclidean distance formula, which is just the point distance formula that we all know. And the test passes, and of course, if you were writing this, I would expect you to do more test cases. But one thing we could do, and this is kind of interesting, is that let's say we want to compute the distance from P2 to, let's say another point, like new point, -3, 10. So you can actually instantiate a point directly inside of this method. So it receives a point, so it doesn't matter where we create the point, it just matters that the thing we give it is a point. So using my handy-dandy calculator, I'll find the distance very quickly. Let's see, 4, 5, -3, 10. So it's approximately 8.6. And I'll use a delta because whenever you're working with square roots or anything like that, you should probably always use a delta. And all tests pass.